Bismillahirrahmanirrahim. Dear students, I am Nadeem Khan from JK College. Today we are going to discuss class 10th, chapter number 11, organic chemistry, and the topic is chemical diversity and magnitude of organic compounds. So in this topic we will study the reason that why organic compounds are so huge in number. Millions of organic compounds have been discovered, prepared and isolated from plants and animals. So why they are so great in number? So the chemical diversity means here they are diverse, they are large, they have a lot of varieties. So this is the main reason. Today let me discuss, there are three reasons due to which are responsible for the chemical diversity and the magnitude of organic compounds. The first reason is catenation. Catenation. It is also called self linkage property. Dear students, you know carbon can form four covalent bonds. So carbon atoms have a unique ability to link up with each other to form long chains. They can also give branches. They can also form close rings of various sizes and shapes. This ability, due to which the carbon can form long chains, it can give branches, it can form the close rings of variable sizes and shapes. This unique ability of carbon atom is called catenation or self-linkage. Why organic compounds are so great in number? Because in one compound, carbon atoms are arranged in one pattern, while in other compounds, let's say this is an organic compound. If I remove this and put it here, this is a separate compound. If I put another branch here, this is a separate compound. So in this way, it has a large number of compounds. Carbon can form large number of compounds by changing the pattern of or connectivity of the carbon atoms. So now this is the first reason for the that is the catenation, and this is the unique ability associated only with carbon. Silicon also shows the similar behavior, but its catenation ability is very poor as compared to carbon. Now, another reason for the chemical diversity of organic compound is the isomerism. Isomerism. Let me draw a compound like this. Dear, you know carbon can form four bonds. How many bonds this carbon has formed? One. So write three bonds here and three hydrogen atoms. How many bonds this carbon atom has formed? Two. So put two hydrogen here. Two. So two hydrogens, and this carbon again have formed only one bond. So carbon can form four bonds. So always satisfy the valency of carbon with four bonds. Now look at this compound. What is this? CH3 bond CH2 bond CH2 bond CH3. This compound has four carbon atoms. It is called N-butane. It's called what? N-butane. It has formula. Check it. Carbon 1, 2, 3, 4. 4 carbon atoms. C4. 4 carbon atoms. How many hydrogen? 3, 2, 5, 2, 7, 3, 10. C4H10. So this compound has a molecular formula C4H10. Now let me draw another structure. Look at this. Where are lines? These are the hydrogen atoms. Now look at this compound. It has how many carbon atoms? 1, 2, 3, 4. How many hydrogens? 3 here, 3 here, 3 here, hydrogen atoms, and 1 here. 3, 3, 6, 3, 9, 1, 10. 3 carbon atoms and 10 4 hydrogen atoms and 10 4 carbon atoms and 10 hydrogen atoms. So again, this compound also has the same formula. This is the same formula. So these two compounds, it has a straight chain structure, it has one branch here. If I draw it in condensed form, this will be something like this. What is this? CH3. Then bond, CH, and here CH3, and above again CH3. This is also butane with the same formula, but it has a branch. This is straight chain, it's called N-butane. N means normal straight chain. This is called isobutane. This is called isobutane. So both these compounds have same molecular formula but different structures. These two compounds are said to be the isomers of each other, and this phenomena is called isomerism. So due to the isomerism, the carbon can show chemical diversity. I mean, it can form a number of compounds. So that's why they are so large in number. The third reason for chemical diversity of organic compound is that what we call multiple bond formation. This is one of the ability of the carbon atom, that it can form multiple bonds. Multiple bond mean double bond and triple bond. So carbon can form double bond, carbon can form triple bond in addition to single bonds. So let's say this is a single bond, this is a double bond between two carbon atoms, this is a triple bond between two carbon atoms. So not only between the carbon atom, the carbon can also form bonds with other atoms like oxygen. Similarly, the carbon can also form triple bond with the nitrogen and phosphorus, sulfur, and many other compounds. So this is the third reason. So let me summarize my discussion that carbon has a great chemical diversity. Why? Because of the three reasons. The first reason was the catenation or self-linkage property, due to which the carbon can form a large number of compounds by changing the pattern of the carbon atoms in various manners. The second reason was isomerism. Okay, now I have discussed the isomerism in butane. Isomerism in pentane is also mentioned in your book, you can check it. The third reason which I have discussed now is the multiple bond formation. Carbon can form multiple bonds not only between the carbon-carbon atom, but it can also form the multiple bonds with the many other atoms like oxygen. Similarly, we can also put sulfur here. It has formed the bond with the nitrogen. We can also put phosphorus here. Okay, so this is the main reason for the chemical diversity of organic compound. You can check this topic in your book. Thank you.